All right, so couple of things. Thank you to those who are communicating with me, letting me know when you've got issues. Hopefully I'm accommodating you if you had an issue with CK12. If you're showing me a screenshot, I'm opening that back up so you can finish. What are some other issues? Just how to enter stuff in WebWork. Sometimes that's the hardest part. Not really understanding the system yet. So if you've got issues on how to enter stuff, make sure you're sending me a text or an email, and I can look at it and tell you what you're doing wrong. Okay, so thanks for communicating with that. I did get one message like at 10:30 last night that I saw this morning. So I will tell you, I go to bed about 9. I try to, because I'm up about 5:30 every day. So I'm probably not going to answer you if it's after 9 o'clock. But feel free to email. I can get back to you the next day. Okay. We'll go through the textbook quiz, and then we do have a quiz on sections 1.1 through 1.4 on Friday, or Monday, sorry. So after we kind of go through this quiz, I'm just going to let you know a little bit about what's going to be on that quiz, so you can do whatever studying you might want to before Monday, and then give you the rest of the period to finish 1.3, ask questions on 1.3, and then get to work on 1.4. Okay. So the first one, again, just trying to encourage you to watch all the videos I put in. There was the first video that was talking about solving two-step equations, and I stopped the video and I put a comment in and asked or told you something that I like to do. And which one of these was it? Anybody watch the video? The first one. I like to add 5x to both sides. So if I have a question where my variable's on the right, and I've got a constant and a variable on the left, a lot of times I like to move my variable to the left so I end up with a y equals or an x equals. You don't have to, and as you get better with math, you don't have to do that. You'll be able to move it around pretty easily. But for you guys, I would like to, that would be something that would be helpful, is to just try and keep your variables on the left and your constants on the right. Not a requirement, but just a helpful hint. Okay, number 2, in the section on solving two-step equations, both the video and the textbook refer to using the least common denominator method. So if you use that method in the problem below, what would you multiply each term by? Any idea? 12. Does everybody understand that method? Because I love to get rid of fractions. You're probably different than I am. You probably love fractions, but I don't like them that well. And if I can eliminate fractions entirely from a problem before I even start it, then I don't have to worry about adding fractions, multiplying fractions, anything like that as I go. Does anybody want me to do this problem really quickly using the least common denominator method to get rid of fractions? Or do you know what I'm talking about when I say that? Want me to do it? Or you know what I'm talking about? You're shaking your head, but I don't know. You know what I'm talking about? And I can do it real quick. 3/4 x minus 2/3 equals 7/2. Okay, so one way to do this problem is to add 2/3, get a common denominator, get that fraction simplified, then I multiply by the reciprocal to get rid of the 3/4, right? But that's not very attractive to me because I'm having to deal with a lot of fractions. So the least common denominator method just simply says if you multiply every term in here by the common denominator, as if you were adding all of those fractions together, and we already identified the common denominator to be 12, right? So if I multiply every term by 12, I can eliminate my fractions from the get-go and not have to worry about them later. Okay, so if I multiply 3/4 by 12, what do I get? What'd you say?
36.
Which is 9. Okay, to do this fraction, multiply, just a quick review. One way to do it is multiply the numerators across and the denominators across, right? I personally like to simplify first. So I can see, if you remember, order doesn't matter, commutative property with multiplication. I could rewrite this times like that, right? Just switch the numerator, because order doesn't matter. And 12/4 is 3. 3 times 3 is 9. That's the way I do my fractions when I multiply in my head. I try and simplify it first. But you could multiply across 36 divided by 4. That's also 9. Okay? So I have 9x. 12 times 2/3 is either 24 thirds, or recognize that 12 over 3 is 4 times 2 is 8. Either way, you get 8. Okay? And 12 times 7 halves is 6 times 7, right? 12 over 2 is 6 times 7 is 42. This, to me, is a much simpler problem to deal with than this one. Everybody agree? Yeah. So that's the least common denominator method. Get rid of your fractions before you even start. Okay? All right, so long story short, answer to, come on, that problem is 12. Okay. Question 3. In the first page of the textbook for section 1.4, there was a real-life problem discussing two friends, Alex and Gabriel, who lived 380 miles apart. According to the textbook, what state did they live in? Anybody remember that? California? When solving for x in the following equation, what number would you multiply both sides by? 4/5. Just the reciprocal, right? You could divide by 5/4. But when you divide by a fraction, you what? Multiply by the reciprocal. Have that mantra always in your head. Okay. 4/5. Good. The last question, in solving two-step equations that involve addition, subtraction, and multiplication, division, the first step is to undo an operation using multiplication, division. False. We talked about that even yesterday. Following the reverse order of the order of operations, the first thing you'll do is the addition, subtraction. Second thing would be multiplication, division. Questions on any of that? Okay, so I'm going to just talk to you about a few things that will be on the quiz on Monday, just so that you're prepared. You're going to have a question that's going to require you to graph a number on a number line, two numbers on a number line. One might be a radical, like square root of 3, and one might be a fraction or a decimal. Okay, and you'll have to pick. This is a multiple choice test. You'll pick which graph represents those two numbers on a number line. So what's the easiest way to graph numbers on a number line when they're like one's a radical and one's a fraction? Yeah, convert the numbers to a decimal. You can use a calculator on the quiz. Okay, so convert your numbers to a decimal and then compare them. Okay. Know your properties. Know your commutative, associative, inverse, additive identity, all those properties. You'll have one question on there that says which property is this kind of question. Okay. There'll be a couple questions that they'll want you to evaluate expressions given certain values. If I have 3a plus 6 and a is 7, what's the expression? So it's just plugging that number in, right? Pretty easy. Simplifying expressions using your order of operations. You know, if you have you may have to use the distributive property. Remember, this is something that gets a lot of people. Remember, when I am subtracting, there's a subtraction sign before a parenthesis, treat it as if there's a -1 there, and distribute a -1 to both terms. Many times, this is where you'll mess up. You'll distribute that -1 to the -2, and you'll call this you'll forget to distribute the -1 to the second term. Okay, so just make sure when you've got a negative in front of the parentheses, you're distributing it to every term. Okay, but that's kind of a problem talking about simplifying expressions, simplifying that expression and then getting your like terms and going on. But this should have been a -x. So this would be 2x plus 4 simplified. Okay, so there'll be a problem or two like that. There's going to be a problem, probably two problems that may have a problem like that, and it's going to give you 4 solutions, and it's going to say which one of these solutions is the solution to this problem. to me, rather than go through every choice and plug it in, it's just easier to solve for n and then pick the answer. You know what I mean? But do it either way because you're going to have multiple choice. And the ACT is multiple choice. So, you know, you have two choices when you do questions like that on the ACT. You go in and plug every answer in or just solve it. And you're trying to make it as fast as possible. So solving is, to me, faster than plugging every answer in. But it's your choice. Okay, and then you're going to have a couple problems where you're going to have multiple variables in an equation solving for one of those, like we did with a equals 1/2 base times height the other day. So I'm going to give you an example of a problem, and we'll talk through it together real quick just to make sure you're ready for this on Monday. Solve for D. There's only one variable D. Solve for it. So what do I do here? D is what I'm trying to eliminate. Sam, did you have a thought? Multiply both by D. Okay, so my first step might be to get D out of this denominator because ultimately I want to get D by itself. Okay, before I even start this problem, can I just eliminate these D's altogether because I have a D on top and a D on bottom and D divided by D is just 1? Is that possible? It's a trick question. I can tell you're thinking that. It's not. It's not. If I have 3 plus x over x, I can't just say that's 1, so the answer is 3. Okay, the reason, if that were true, 3 plus 2 over 2 would be 3. But 3 plus 2 over 2 is 5/2. Right? It's an easy mistake to make. And in fact, I think one of the problems in web work that you had like 6 questions that you had to answer true or false. Was that 1.2 or 1.3? I can't remember. One of those problems was similar to this. And many people were missing that problem because I put true here. And it's not. It's false. Okay? You cannot simplify when you have addition or subtraction. You can when you have multiplication. But if they're connected by a sum or a difference, you cannot just cancel them out. It doesn't work. Okay, I went off track. So let's look at this. Sam said multiply both sides by D to eliminate D. Everybody with me so far? Okay, so what this does, because this is multiplication, not addition or subtraction, this does eliminate the D. Okay, and on the left then I have dB equals C minus D. I'm trying to get D by itself. So the next step really is to get everything with the variable you're trying to eliminate or get by itself on one side and everything without that variable on another. Remember, each of the other variables are really just standing for numbers. So if you treat them like numbers, if I had 3D equals C minus, or sorry, I don't want to do C, 4 minus D, what would my next step be? Add D. Same thing here. Okay, I'm just going to add D. So now I have D plus dB equals C. How can I get D by itself eventually? What can I do to those two terms? What's common to both of those terms? What's a factor of both of those terms? D and dB. What's common factor? D. Does everybody see that? D's in both. It's a factor of both. So I'm going to pull the factor out. When I pull that factor out, I pull D, out of itself. What do I get? The first term. Look, just looking at the D by itself. I pull the D out. What'd you say?
D squared.
So if I multiply D by D squared, I'll get D. What do I multiply D by to get itself? Identity property, right? 1. If I factor d out of itself, I'm left with 1. Everybody with me? Now if I factor d out of db, what am I left with? b, right? I could test it. Just go ahead and distribute the d back through. Do I get d plus db? Yeah. So we have to get d by itself. The only way I can do that is to factor a d out of both terms. Now how do I solve for d? d is multiplied by a number. That number is 1 plus b. So how do I undo that operation? What number is it multiplied by? 1 plus b. So how do I undo multiplication? Divide. So I have to divide by the same number, 1 plus b. That's what d is equal to. C divided by 1 plus b. There's going to be a problem on the quiz nearly identical to this one, different variables. Okay, so if you need to rewatch this recording this weekend just to get ready and know how to do it, then do that. Prepare yourself. Okay, the key here is getting all of the variable terms that you're looking for, in this case it was d, on the one side of the equation, everything without d on the other, and then recognizing you've got to eliminate, you're trying to factor d out so that you can solve for d. And to do that then, I had to pull a 1 and a b out of that expression. So then I could divide by that and get a d by itself. Okay, you're going to have a couple problems where you're going to have to eliminate or isolate a variable and solve for it when you've got multiple variables in an equation. So just do some practice problems on that with yourself. Make sure you're ready. Okay? So that's going to be the quiz Monday covering 1 through 1-4. That means Monday morning we aren't going to have a textbook and video check on 1-5. We won't do that until Tuesday morning. Okay, so the only thing you've got to do this weekend is just prepare yourself for the quiz. Okay, 1-3, it will be due tonight. I can't remember, can someone look up and see when 1-4 is due? Is it, is that a Sunday or is that Monday? Today's the 25th. So what I think I might do is move that deadline to the 28th, because the purpose of my deadlines is to give you that extra day in class to ask questions. That way you guys can work on web work for 1-4 over the weekend if you need to, and then come Monday morning with whatever questions you have that we can talk through after the quiz. Okay, so I'll just move that over. In fact, I'm going to do it now so I don't forget. Okay, and we are I want this over. Okay, everything's been moved to Monday now. All right, any other questions? Okay, otherwise go ahead and get to work on 1-3 and 1-4, wherever you're at.